All right, good morning and welcome to the rebroadcast of the interrupted Mind at Home. I apologize for the technical glitch that happened just now. As you can see, it's very hot here, and I think my phone just became a victim of the extreme heat. My phone just suddenly said that it is too hot, and I am also sweating. So again, I apologize to all our viewers for the technical glitch that interrupted our broadcast. So thank you very much for watching once again. And again, for those who are just joining us, I apologize for the technical glitch that occurred because of the extreme temperature. It's so hot here and I'm sweating, and my cell phone became a victim of that heat. So a reminder for our viewers that aside from just staying at home and washing your hands, also remember to hydrate all the time and be in a ventilated area where there is circulation of air if you can, right? In order to avoid what happened to my cell phone wherein it overheated, right? So again, I apologize for that technical glitch, and thank you very much for coming back here to watch our science experiment. And I hope that the technical difficulty will not occur again. So let me start over. All right, so good morning. My name is Mind Mover Pecier, and I'm one of the science communicators from the Mind Museum. Welcome to another installment of Mind at Home, where we, from the Mind Museum, show you science activities that you can do at home with simple materials that you can do to have fun and learn at the same time. So of course, we're right now in the middle of a global pandemic, and we're asked to stay at home as much as possible. And while we're at home, we should wash our hands with soap and running water for at least 20 seconds. Right? So we all need to do our share to help slow down the spread of the disease COVID-19 and to flatten the curve. And while we're at home, it can be stressful during quarantine. So we here at the Mind Museum have made Mind at Home so that we can have fun while learning at the same time. Because as the U.S. Centers for Disease Control and for Prevention, or the CDC, has shared, right, doing something you enjoy while having fun at the same time and learning is something that can really help with the stresses of the situation of being in quarantine. All right, so let me show you the materials you need for the experiment. So for the experiment, here are the materials you need. So you're going to need a bottle. Any kind of bottle will do. The next material you're going to need is a coin. So let me be a vlogger and show you the materials needed. There you go. All right. So in the case of this bottle that I have, the coin that is appropriate for it is a 25 centavo coin. Yan ang benching ko. Kasi kasya siya because it fits, right? So any kind of coin will do as long as it can fit into the mouth of the bottle you have. And the third material we're going to need is a loop or a ring. So what I happen to have here is a double-sided tape, right? So if you don't have a double-sided tape at home, you might have a Scotch tape or a clear tape. No? Any kind of tape would do, right? So if you don't have those materials, I'm going to show you alternatives later. No? So kung wala kayong ganito sa bahay, any kind of ring or loop or a ball, I'm going to show you alternatives that you can do. Okay, so let me now start with the experiment now that we know the three materials needed. Okay, so I am going to show you that the bottle is empty. Wala siyang laman. Alright, I'm going to put it there. And then, I'm going to put the loop on top of the bottle. Patong ko siya. Like so. And then, I'm going to put the 25 centavo coin. Right? Yung benching ko, lagay ko dito sa taas. Okay. And then I have to make sure that they're aligned. No? Dapat siguraduhin kong naka-line up sila. Okay. Now, here is the challenge. You have to remove the loop, tatanggalin niyo yung loop. Bawal yung hawakan yung coin. You're not allowed to touch the coin. But the coin must shoot into the bottle. Okay? So let's see if I can do it in the first try. So the key here is to just flick it really fast, like so, and shoot siya. As you can see, there's now one coin inside. Let me try it a second time as I explain the science behind this simple experiment, right? And I can sense na many of you na-challenge na like, oh, wow, how's that possible? Baka pwede ko rin yung gawin sa bahay. So I'd like you to try that later at home. So again, let me try an older 25 centavo coin this time. Let me put it there, okay? And let me try to flick it. And of course, the science behind this experiment is what we call inertia. There you go. So inertia is the, baliktad yung word inertia. So inertia is when, it's the tendency of things, in fact, to not change the way they move, right? Unless there's an imbalance in the force. So in other words, when things are at rest, pag hindi gumagalaw yung coin, it tends to stay at rest. So tendency ng coin natin to remain at rest, right? So tignan natin, I'm gonna flick it again, right? And as you can see, may dalawang coins na tayo sa loob, right? So na-shoot din siya. Okay, so the secret here again is inertia, the inertia of our coin. I'm gonna do it a third time. Okay. So dito, when I put the coin on top of the loop, pag pinatong ko siya dyan, right, there are many forces acting on the coin. Maraming forces na tumutulak sa coin. But they all balance each other out, right? So they balance each other out. That's why the coin is not moving. Now, inertia says that in order to make that coin move, there has to be an imbalance in the force. Kailangan may imbalance sa force. May isang force na mas malakas kumpara sa iba. Right? So, expert level, thank you. Yes, I've practiced this a lot. Right? So, there should be an imbalance in the force, and the imbalance in the force is what will make our coin move. But remember, our coin starts at rest. Right? And because it starts at rest, its initial speed, yung initial niya na bilis, is 0. Right? Hindi siya gumagalaw. And therefore, pag 0 yung speed niya, magsisimula pa lang siyang gumalaw. It's gonna start to move, right? And it's gonna accelerate, is what it's called, right? Because there's now an imbalance in the force. One force is stronger than all the others. And that imbalance in the force is gonna make it start to move from 0. Pero dahil nagsimula siya sa 0, it's gonna start slow. You are gonna have enough time to get the loop out of the way. So pwede mong tanggalin yung loop. Now that I've shown that I can do it 3 times straight, let me try extra challenge level, right? Dagdagan natin. Let's escalate the difficulty. Okay? So I'm gonna use 3 coins, maybe 4. I'm getting confident. Let's use 4 coins, right? All stacked like this on top of our loop. Now, as you can see, there's 3 coins sa loob. Let me take them out, all out. There's no more coins inside. I'm gonna put it there. Here you go. Okay, now let's see if I can do this in one attempt. Oopsie. I have to make sure it's aligned. Lined up perfectly. Alright, and then the secret is you have to flick it real fast to make sure that there's not enough time for the loop to be in the way of the falling coins. Oh, sorry, there. So I was not able to do it in that attempt. So in science, we learn by trial and error. So that was the error part just now. So you can see the error I made was I hesitated. So the secret is to not hesitate. So just flick it with confidence. Right? So yesterday, this perfect technique of flicking it with confidence was taught to me by my girlfriend. She showed me that she was able to do it using that technique, 9 out of 9 times. 9 times straight, successively. All of them were successes. So let me try it again. One last time with this extra level of challenge. Oopsie. Alright, and the secret is to flick it. Here you go. And then we have the coins inside, right? Alright, so what if, the question now is, what if you don't have a loop at home? What are the variations? Ano yung mga pwede ninyong gawin pag wala kayong loop? So I'll show you a variation to this experiment that shows you the same concept. So I'm gonna put you here. There you go. Alright, so I'm gonna empty our bottle again para wala na siyang laman. Okay, so as you can see, wow, it's very hot. Okay, you can use any piece of paper, right? And then you're gonna put your coins on top of the paper. like so. So I have a stack of coins here. Yan, meron akong mga coins. Tapos lagay ko dito. Okay. As you can see, the coins are on top. And then you have to make sure na align din sila. And then, like in that famous tablecloth pulling experiment, you're just gonna pull it, just like the tablecloth. And again, the concept here is also inertia. The tendency of the coins to want to stay at rest. And because they have the tendency to want to stay at rest, if I yank the piece of paper fast enough, there we go, oops, some of the coins are left. Let me try one more time. There we go. So if you yank the piece of paper fast enough, the coins are not gonna have enough time to go with a piece of paper, no? To go with a piece of paper. They're gonna stay there, they're gonna tend to stay there, and they're gonna shoot into your bottle. Okay, now I've done that, ginawa ko siya with a stack of coins. Right? A stack of coins. Now my question is, yung tanong ko, will it be easier if it's just one coin? So I'll give you a few moments, I'll try it again. So isang coin lang, one coin, right? I'll put it on this paper again, right? And then we'll try that experiment. So will it be easier or more difficult? And why? Okay, so let me try the experiment. Again, we have one coin here. There you go. Let me try the experiment again. Right, so the coin did not shoot into the bottle. The coin went with a piece of paper. Sumabay siya sa papel. Now, so we can see that it is actually more difficult, itong variation na to, with just one coin. Pag isang coin lang, mas mahirap. Bakit kaya? What is the difference between just one coin and a stack of coins? So the difference, you're correct, the difference is mass. Mas mabigat ang stack of coins. It's more massive. There's more stuff in a stack of coins than in just one coin. And because this has more mass, according to another law of motion, the second law of motion, it will have more inertia. So that's what we see. The more mass something has, the more stuff there are, pag mas mabigat siya, the more inertia it will have. Mas malakas ang tendency niya na hindi gumalaw. The more it will resist a change in motion. So, if we have a stack of coins, and let me do that again with a stack of coins, right? It is more massive, like that, here you go. It has more mass, mas mabigat siya, and therefore it has more inertia. And because it has more inertia, when I pull the piece of paper, right, the friction between the paper and the coins won't be able to make the stack of coins move by a lot. Okay? So let me pull once more with a stack of coins. And as you saw earlier, it was more difficult with just a single coin. Let's see now if it will be easier with a stack of coins. There we go. So the stack of coins goes into there. So there we see another law of motion. It's not just that things have inertia, which is according to the first law of motion. And to review the inertia, the concept of inertia is just the tendency of objects to, if they're at rest, stay at rest, unless they're acted on by an imbalance in forces. And the second law of motion is that the more massive something is, the more stuff, the more the inertia. Alright? So, I'm sure that you are challenged by this experiment and you'd like to do it at home in all its variations. If you have this, try this variation. It's really challenging and it's fun if you've mastered it. Masaya siya pag na-master niyo na. Right? And if you don't have a loop like that at home, you can try the variation that's like this. Or if you don't have a piece of paper lying around, you can use a paper bill is another option. So let me now see if you have questions in the comments. Leave comments for questions. And again, for those who returned, thank you for coming back. I apologize for the interruption in our broadcast earlier, which happened because it's very hot right now. And my phone overheated and As you can see, I'm also sweating a lot, which is a reminder to all of us to be in a ventilated place and hydrate because it's very hot and very humid in the coming days, like yesterday, for example. So let me see some of the questions. How tall of a stack until it would be too difficult to move the paper away? That is an excellent question. So I unfortunately do not have enough coins here. I just have these many 25 centavo coins, which is again the coin that happens to be the same size as the opening of my bottle. If I put them here on top, right? So let me put you again where you can see it. All right. So here you go. Right. It's still possible to do it, right? So all the coins got in. I think it depends on the stiffness of your paper. When your stack of coins is so high that the paper starts to make a sort of valley into the bottle's mouth, something like that, starts to go in because the weight of the coins push it in, then it will be difficult to do this trick. Because this trick relies on the fact that the piece of paper should be flat and should be easy to pull without hitting a snag, right? And without wobbling your bottle. So thank you for that question. What if you use Mentos and then soft drinks inside? Oh, okay. So that's an excellent question. What if you use Mentos with some soda inside your bottle? I'm finding it hard to imagine how to stack the Mentos in the way that you can stack the coins, like so, right? And I'm finding it hard to imagine what would be a mechanism, unless you can make a sort of contraption which we have in the museum. A contraption where we would put the Mentos, right, in the contraption, and then there's a barrier, and then if we remove the barrier, the Mentos would at first start at rest, again because of inertia, but then would start to go down and then would hit the soda, or the soft drinks as we Filipinos call it, and then lots of bubbles would form, and then the bubbles would try to escape, and then we'll have a soda fountain. Right. Someone said, oh, they thought it was because I ran out of battery. Oh, I was actually charging my cell phone, which might be part of the reason why the broadcast was interrupted earlier. But thank you for coming back here. Yeah, it's really hot. My cell phone said it was just so hot. And again, a reminder for all of us to stay hydrated during these really hot times. We have another question. What are some of the applications of the laws of motion when you are in outer space? Excellent question. Here's one application that I find really amazing and interesting. Here on Earth, dito sa Earth, pag dito tayo sa daigdig, we tend to equate two concepts because they go hand in hand here on Earth. And that is weight, yung bigat, how hard it is to carry something, right, weight. And then mass, which is how difficult it is to push something, right? The inertia of something. For example, a heavy cabinet, right, which is hard to lift, is also a massive cabinet, which means it is hard to push, right? And here on Earth, we take that for granted, that they're the same. When we say something, oh, it's heavy, it's hard to lift, oh, then it's also hard to push. But in outer space, they're not the same. They become different because in outer space, things are weightless. Wala silang weight. So walang bigat. There's no weight. It does not take any force to lift things because things float. As we know from videos in the International Space Station, things are weightless. Amazing thing is things have mass. That means a massive cabinet, it won't take any force to lift that massive cabinet in space. Kasi it's weightless in space because it's weightless. but it's still gonna be difficult to push that cabinet. It's still gonna have a lot of inertia. And I've never been to space, but I think that's gonna be a weird experience when you're an astronaut. To see something weightless, that you can lift it as easily as a feather, but still massive, that it's gonna be hard to push, right? So what is inertia? Inertia, let me recap, is the tendency of things to resist a change in motion. So that means when they're not moving, they try to resist a push to move. But if they're already moving, they try to resist a change in that motion. So when they're at rest, they want to stay at rest. And when they're already moving, they want to keep on moving. So that is inertia. Right, so let me see other questions that might be there. Will any work for a container for any? Yes, it can work for any container, and it does not need to be coins. It can be anything that would fit your container, right? But as we've learned already, the more massive the thing is, the easier this experiment will be. And why? Because the more massive something is, the more inertia it will have. The more inertia it will have, the more it will stay there. All right, so let me see if we have a few more questions. So thank you for those questions. Oh, there's a follow-up question, will it explode like a volcano? Yeah, as I said earlier, once the Mentos gets into the soda, there will be a fountain that will look like a bit of a volcanic explosion or a volcanic eruption. All right? Okay, so if there are no more questions, I'm gonna do the experiment one last time for those who've just joined us. So again, this experiment is about inertia, okay, or the tendency of objects to resist a change in motion. In the case of this experiment, it's the tendency of objects that are at rest to remain at rest. So for this experiment, one variation, the variation I like is we have a bottle, which is now empty, walang laman. We're gonna put our loop there. Okay, that's the second material. And then a coin. So in the case here, a 25 centavo coin, 25, right? Because it's the one that fits into our bottle. Okay, and then for this experiment, you're gonna have to flick the loop really quickly so that it shoots into the bottle. Oops, did that work right there? So let me try again. So it can be a game at home. Who is best? Who can shoot it the most number of times, consistently, right? So it can be a sort of minute to win it. How many times you can shoot a coin? So make sure it's aligned like that. Make sure naka-line up siya. Make sure that everything's aligned, and then you just flick it really quick, right? Until you are able to master it. Okay, so it seems that it's not working for me this time. I need more practice, right? So this technique was discovered by my girlfriend. She taught it to me yesterday. She was able to do it consistently 9 times. Let me see if I can do it. There you go, finally. All right, so after the 3rd try. And if you don't have a loop like that at home, another variation is to have a piece of paper. You can have you can use a paper bill if you want to. And then put your stack of coins on top, right? Like that. And then pull like that, all right? Pull really quickly. So I should pull more faster. Really fast until it shoots into the bottle, right? It should be really fast. Okay, I think we have one more question. May isang pahabol na question. Will it make a difference if the tape is smaller or it's an electrical tape? So, an electrical tape I think won't make much of a difference. If it's smaller, I think it will be more difficult. It's gonna be more difficult because there's a shorter distance between where the coin is and the mouth of the bottle. So the shorter distance means shorter time of travel. With a bigger loop, there's a longer distance. That means the coin will take longer to get to the mouth. So you have more time, a better chance to get the loop out of the way, right? But again, the secret is to just flick it real fast so that it shoots into the mouth of the bottle. All right, so there you go. So thank you very much for joining me in this session of Mind at Home. We hope that you enjoyed it, and we hope you've learned a lot, and we hope that you were challenged enough to want to try to do this at home in all its different variations and to learn about the laws of motion. Particular, the first law of motion, which tells us about inertia, and the second law of motion, which tells us that inertia is related to mass, or how massive things are. Okay, so thank you very much, and please don't forget to like and subscribe to the Mind Museum in Facebook and Instagram so that you get updates on when our next activities will be. Our next Mind at Home will be on Tuesday, right? And then we'll be followed by another one on Thursday, still at 11 in the morning, when another Mind Mover or science communicator from the Mind Museum will show you how to do science experiments at home using materials you probably already have. So thank you very much for watching. A reminder to everyone to stay at home as much as possible unless you have to go and get some supplies, and only one at a time. Keep social distance when you leave the house, and don't forget to wash your hands with soap and running water. And don't forget that when you're once back at home, again, wash your hands and you can learn and have fun at the same time. Thank you very much for all those who are watching, and I hope you enjoyed it. Goodbye, and see you in the next Mind at Home.